we can move ahead with our next presenter. Mr. Rana Shahid Asghar from UET Taxila. Are you with me? Mr. Rana Shahid Asghar from UET Taxila. He will be speaking about experimental study of a flow through permeable spur dikes in a rectangular channel. So, Mr. Asghar Rana, 10 minutes for you. Please go ahead, unmute your mic.
Right, sir. Dear sir, can you listen me?
I can hear you, but please speak loudly or bring your mic close to yourself.
Right, sir. Thank you. Can you see my slide, sir?
Yes, we can see your slides, but still your voice is low. Okay,
Just
please go ahead.
Yes, sir. Thank you. Bismillahirrahmanirrahim. Assalamu alaikum to all listeners. My name is Rana Shahid Asghar, and I am here to present my topic, that is experimental study of flow through permeable spur dike in a rectangular channel. And my supervisor is Dr. Gufran Ahmad Pasha. First of all is the sequence of my presentation. That first one is introduction, second one is flume characteristics and experimental procedure, third one is results and discussions, fourth one is conclusion, and fifth one is references. I will start my presentation with introduction. First are spur dikes. What are spur dikes? Spur dikes are basically environmental structures that are put in place to prevent bank erosions and redirect water flow. Spur dikes are basically constructed from the bank of a stream to some angle to the main flow directions. Spur dikes creates a slack flow with the object of silting up the area in the vicinity of river bank. Construction of spur dikes on the river banks mainly depends upon design parameters such as hydraulic properties, which are discharge, water level, velocity, length and width of spur dike, angle of construction of spur dike, and spacing between spur dike. Spur dikes can be immersed, submerged, permeable, and impermeable. In case of permeable spur dikes, flow partially penetrates through the structures, which results in velocity reduction, vortex strength in the spur dike field as compared to the impermeable spur dikes. Permeable spur dikes also has the advantage of being more stable and requires easy maintenance as compared to impermeable spur dikes. Depend upon the construction material. These are the types of the spur dikes. First one is rock dike, rock spur dike. Second one is second filled bag dike. Third one is wooden dike, and fourth one is concrete dike. And next is flume characteristics and experimental procedure. This experiment was performed under different conditions in University of Engineering and Technology, Taxila. And the flume characteristics was that was a glass-sided water flume, constant bed slope of 1 over 500, that is 1 meter in length, 0.30 meter in width, and 0.34 meter in height. The spur dikes that were used in the channel was 0.1 meter in length, 0.08 meter in height, and 0.02 meter in thickness, and spacing between the spur dikes was 1.5 L, where L is the length of the spur dike. A small scale of wooden spur dike was designed to analyze the water depths across the flow, water depth on each spur dike head along the flow. A high-speed digital camera was used to monitor the recirculation zone in each spur dike field with varying porosity. These are the diagrams. First one is figure 1A shows the schematic diagram of the water channel. This figure basically shows how the spur dikes were placed in the lab channel, and second figure, figure 2A, basically shows the top view of the spur dikes placing, which is at 1.5 L distance from each other. And the figure 2B basically shows the porosities of the spur dikes. First one is 4%, second one is 8%, third one is 12%, and fourth one is 16%. Results and discussions. Basic calculation of water surface profile along the flow at head of spur dikes. If you see the figure 3a, you can this is the basically plan of the placing of spur dikes. The yellow rectangles basically are the spur dikes, and the distance between each spur dikes is 15 centimeter, as you can see. And the area between two spur dikes is basically a spur dike field. And if you see the figure 3b, these are the basically results in the form of graphs. If you see the orange line, this line shows basically the water surface depth at 0% porosity. If you see the green line, this is basically shows the water level depth at 4% porosity, and similarly purple line, red line, and brown line. Brown line basically shows the water depth at head of each spur dike at 16% porosity. And here is the results. These basically this clearly shows that with the decrease in water depth, turbulences on each spur dikes had decreases. As you see in the figure, as we increases the porosities, the water depth at head of each spur dikes decreases. As you can see, the brown line, basically this is the water depth profile at 16% porosity. You can see that as we increase porosities, water depth decreases. During floods, it has been observed that head of impermeable spur dikes damages or vanishes away. Permeable spur dikes in flood conditions are more suitable because results shows that it can bear the thrust by passing wave of flood through pores, so minimize the turbulences generated on the spur dike head. Second one is calculation of water surface profile across the flow in spur dike field. Yes, again there is a plan, and you can see B1 dash. These are the sections that are and B2 dash, B3 dash, and B4 dash. In this research, I have just taken two spur dike fields, that is B2 dash and B3 dash. If you see the results, these are the results in figure 4b and 4c. Figure 4b basically shows the water surface depths across the flow in spur dike second, and figure 4c basically shows the spur dike results in water depth results in spur dike field 3. And if you see clearly sees that as the porosity level increases, water depth in spur dike fields decreases. So with the increase of porosity levels, turbulences in the spur dike field also decreases. Yes, you can see the in figure 4b, the sky blue line clearly shows that as we increasing the porosity level, the turbulences and water depth goes on decreasing. Similarly, same is the figure 4c. These are the results of the spur dike field number 3, and we can clearly see is that the same pattern has been going on. And third, trend of recirculation zone with respect to porosity variations in spur dike fields. These are the basically recirculation zones trends that are showing in figure A, B, C, D, and E. Figure 5A basically clear shows the recirculation trend at 0% porosity. Figure B shows the recirculation trend at 4%. Figure C at 8%. Figure D at 12%, and figure 5E at 16% porosity. If we see the figure A, we can see clearly sees that at 0% porosity, the recirculation zone extends throughout the spur dike field. And if we see figure DE, we can clearly see is that as the porosity level goes on increasing, recirculation zone tends to move towards the forward direction. So we can clearly see that the water coming from the pores directs the water towards the forward direction. And here is a conclusion. During floods, the stability of spur dikes is the main concern. Results shows that by using permeable spur dikes, we can easily pass the flood without causing any damage to the spur dikes, because due to holes in permeable spur dikes, turbulence at the head of spur dikes can be minimized by lowering the water level at the head. Results also shows that overtopping of flood water can also be prevented in permeable spur dikes because water depth in spur dikes field continues to decrease by increasing porosity values. Here are the references, and that's all for my presentation. Thank you very much.
Thank you, Rana Shahid, for your nice presentation talking about permeable spurs to control the erosion on the banks of the river. The study carried out at UET Taxila in a flume